Good morning. Good morning, everyone. Welcome to episode 6 of Loops. For all those that are not familiar with the episode, this is a live webinar series focused on shedding light on the innovation produced by the Horizon 2020 funded projects in the field of social innovation and circular economy. I am Daniela Bruccoli. I'm in charge of the communication at VELFA, and I'm very happy to be here today. And today we're going to dive into the agriculture sector, and we're going to do that with the contribution of the Water2Return project and CYBELE project, with the contribution of Dr. Zapata and Dr. Davy. So before moving into the heart of the episode, I would like our guests to introduce themselves. So Dr. Davy, would you like to start?
Yeah, absolutely. Thanks, and nice to be here as well. My name is Dr. Stephen Davy. I work as Head of Division for Programmable Autonomous Systems at Walton Institute for Information Communications and System Sciences. I'm also the project coordinator for H2020 project CYBELE.
So, Dr. Davy, could you try to speak?
Yeah.
Is there a mic problem or? Oh yeah.
Is it okay?
Yeah, now it's fine. Okay, thank you very much. Dr. Zapata?
Hello, good morning, good afternoon. In Spain, it's good morning yet. My name is Pilar Zapata. I come from Bioazul company, which is a Spanish SME. It's a technological engineering and consultancy located in Malaga, in the south of Spain. We take care basically of water management from the technological point of view, but we also have a stronger profile regarding projects and technological consultancy. So we are the coordinators of Water2Return project, and it will be a pleasure to actually present it to all of you.
Thank you very much for this short introduction. Okay, so I'm just going to give the participants a general overview of what the episode will be structured. So now each of the project coordinators is going to deliver a short presentation of their projects. And after that, there's going to be room for a Q&A session. I'm going to ask a few questions to you both. And then, of course, there's going to be room for questions from our audience. So we're really looking forward to hearing from them. And so if you have any questions, submit them in the event page on LinkedIn or during the live streaming on YouTube. So now I'll give the floor to Dr. Davy, who's going to talk about the CYBELE project. So please, the floor is yours.
Thank you. I'm happy to be here as well. And the project I'm going to speak about is the CYBELE. CYBELE project was funded under Horizon ICT 11 and the Horizon 2020. There's 31 partners involved, and there's 14 countries. It's quite a large project. It's a €14 million innovation action. And innovation action, again, it's looking to bring results to the market of research that's being brought into the project. There's 9 demonstrators as part of the project, and I'm going to give a little bit of information on those today. They're all agriculture related. It started on the 1st of January 2019, so we're about 2.5 years into it. We're in the final year now, so we're really looking at exploiting those results from the project. If I was to list a few keywords from the project, it would be high performance computing, big data, artificial intelligence, Internet of Things, precision livestock farming, precision agriculture. Let's just step back and look at the challenge that the project is looking to address. Primarily, it's looking at the issues around food waste and food waste crisis. Amazingly, there's 1/3 of all food that's produced around the world ends up in a landfill and it just goes wasted. So it's a huge social and economic problem. There's also lots of dimensions and challenges around it. It's not just can't just be solved with one technology. There's lots of different aspects to it. The approach that CYBELE is taking is looking at it from a digital transformation perspective, trying to bring digital technologies into agriculture, into the agricultural production value chain, and looking at all the different ways that technology can play a role. You know, technology it's all around, especially in agriculture. Looking at how can, you know, machinery, autonomous systems, or artificial intelligence, or monitoring your field, how can that actually benefit the farm managers? And we're looking at leveraging high performance computing in particular. High performance computing, you can think about it as, you know, these supercomputers that, you know, they predict the weather, or they do, you know, gene code sequencing. They're able to crunch huge amount of numbers, large volumes of data, and we're looking at these technologies as a way of bringing them into agriculture. But one of the main concerns that we have, or that we've seen, is that HPCs, they're just not accessible to most organizations, particularly agri-tech organizations. They don't know how to access them. They don't know how to develop their software to run on these high-performance computing, or even get their data into these platforms. So this is really a difficult challenge for some of these organizations. And then on the other side, we have the European Commission investing in high-performance computing. They want these systems to be used. And so not just by scientists, but also by these potentially startup organizations that want to be able to compete. So we've identified some of the main issues. It's around the lack of big data experience, the lack of artificial intelligence or machine learning expertise, the difficulty in deploying IoT sensor networks, and just the lack of experience in accessing high-performance computing algorithms and processes. What we're hoping to get is to be able to resolve all those issues, so that farm managers and you know, farm food production companies, they will have data at their fingertips, such as weather data, soil temperatures, you know, sea conditions, you know, pollen counts. So all this information at their fingertips, so they'll be able to use it to make more informed decisions around their productions. So being able to classify the quality of crops in different areas, to be able to come up with really targeted fertilization plans. Or if we're looking at livestock farming, potentially being able to identify the optimal weight of pigs for slaughter, or to be able to look at herd behavior in real time. Or if you're looking in the aquaculture area, to be able to pinpoint where is the best location in the open sea to go fishing. And if they can get these better decisions, then they can have much more improved outcomes. So improved outcomes could look like better food quality, longer shelf life, you know, a better way to differentiate their products on the shelf, so they'll have a higher degree of quality in their products, potentially be able to open up new markets for their businesses. And all these would be working towards less food waste, or, you know, better recycling of food. So the project looked at kind of 3 technology areas that we can make enhancements on, and specifically around HPC. So one is HPC abstractions. So that's making HPC environments much more accessible. So by removing the need to have very specialist expertise in these systems. Artificial and machine learning templates. So that's also eliminating the need to have high-skilled expertise in this area. You can use off-the-shelf models and to apply them to your own organization's needs. And also looking at being able to search and query and categorize your data in a very intelligent way, and that's through the intelligent query building interface. Just to look at, you know, briefly, I'm going to take 3 of the scenarios that we look at, but this is the 9 demonstrators here. So we have organic soya yield production, we have food, we have climate services for our organic food production, we have autonomous systems that look at arable crops, we have crop yield prediction systems, and then in precision livestock farming we have pig weight optimization, sustainable pig production, open sea fishing, and aquaculture monitoring and feed optimization. So they're the agriculture scenarios. So I'm going to take just a little bit of detail into three particular areas, just to give you an idea of where HPC comes in and how the CYBELE project adds value. So if we look at pig analysis, for example, pig video analysis, in a typical pig farm, you might have 500 or 600 pigs, but you might only have 3 or 4 manual staff to be able to manage those pigs. And one of the difficult challenges they have is trying to make sure the pigs are at the right weight for slaughter, or also do the pigs exhibit some anomalous behavior? Are they uncomfortable in their pig pens? So we're looking at using computer vision techniques. So computer vision techniques are able to take in a video image, for example, and instead of sending that video off to be looked at by a human, we have trained algorithms to be able to look at that video and, for example, to be able to identify what's the pig weight, or what's the average pig weight in a pig pen, or is there anonymous behaviors from the pigs, and to have that information fed to the pig production managers, rather than them having to look at video or to have staff out looking at each of the pig pens. So it's saving them time and effort, so they can actually be much more effective in their job. So HPCs come are involved because training the camera to be able to actually identify pig weight or identify pig behavior takes a lot of compute power, to get that algorithm, accurate for it to be put onto the camera. So that's where HPCs come into place. So be able to crunch the data to get that algorithm fit for purpose for those cameras. Similarly, if you're looking at satellite imagery, computer vision techniques can be trained as well. And in satellite imagery, the issue there is that there's so much data. There's terabits and terabits of imagery data that would need to be analyzed and processed. And that's some of the challenges that SIA yield prediction is looking at. So in this figure here, we're looking at an overhead satellite view of a typical SIA field. And you can see the gradient in the colors is showing where is a really high quality grain versus lower quality grain. And if you jump to the next part, you can see these classification lines. It's actually showing if the farmer collects the crop in that particular line, they have a class A product, and if they collect it in a red line, they have a class B product. So they can actually separate their products on the farm into higher quality protein, higher quality soybeans, and lower quality. So this is giving them the decision making to be able to differentiate their products. So finally, a use case around wheat ear counting. So this is looking at estimating how much crop could be yielded from a particular field just from drone imagery on the field. And again, how HPCs play involved in this is that they're looking at a lot of data of this imagery, and they need to be able to come up with a very complex model to be able to accurately count how many wheat ears do they see in that picture. So the drone can fly around the field, and the farmer, again, he doesn't just get video imagery up from the drone, he gets a count of how many wheat ears or how much crop he has in his field, and that's done from the algorithms on the camera. So the current status of the project is we're in month 29. The technical architecture has been built and it's deployed across several HPC facilities across Europe. We're evaluating the technology, so that's the usability of it and the business impact benefits to the 9 demonstrators. We're doing that right now, and the results should be out by the end of the year. But initial results are very, very encouraging, particularly around the food safety value chain, pig production, the open sea fishing. What we're hoping to do is bring this technology to market early 2022, and to assess it with these ag tech companies that want to get into the HPC space. So that's a whistle-stop tour of the CYBELE project. It's really excited to present it here today to you, and I'm happy to take any of your questions.
Thank you very much, Dr. Davey, for this insightful presentation of the project. I'll keep the questions for later at the end of both presentations. And now I'll just give the floor to Dr. Zapata to talk about Water2RETURN, and then we'll move to the Q&A sessions for both projects. Thank you.
Thanks a lot. I'm sharing the screen.
One second.
Okay. Do you see it already?
Yes, now we do.
Okay, perfect. Okay, so well, I would like to introduce you Water Treatment Project, which is coordinated by BioAzul, and I would like to explain different aspects of the project itself. But I would like to start with the reasoning why we decided to write this proposal and build up this system. Because as mentioned before, why we bet for water to return. As mentioned before, we are a wastewater treatment company, among other things, and we are quite aware of the wastewater effluent, how it is, how it works, and therefore about its potentiality. We are aware it's a resource. It can be considered actually a resource because it's a source of nutrients that can be used, for example, in agriculture. When thinking about different kinds of industries in which this wastewater was actually as well a problem for them because they were producing a lot and they had to do something with it, food industry came quickly to our mind, especially the European slaughtering sector, because they consume a lot of water and also a lot of energy, and they produce large amounts of waste and wastewater. And when thinking about this and thinking about agriculture and the challenges it's facing currently, and it will face in the future, because by 2050, world population will reach 9.1 billion people. These people will have to be fed, and it will happen in a context in which of climate change, in which the rural labor force will be smaller. There will be land limitations, soil degradation, etc. And also, we have the additional issue of the chemical fertilizers. Their demand is increasing quite a lot, but they can be dangerous for the environment if they, for example, go into any water body. So when mixing all these things together and going back to the slaughtering industry and thinking, okay, which is the current approach for treating this wastewater? What do they do with it? They basically, in generally speaking, tend to get rid of the treated water by fulfilling the legislation, and therefore they also dispose these nutrients. And there is an alternative, more sustainable, and framed within a circular economy approach, which can be the system water to return. It provides a market opportunity, a new market opportunity for the slaughtering industry, because they may have a new product, let's say to sell. It adopts a circular economy approach, extracting the maximum value from the slaughterhouse's effluents, and also makes possible to recover nutrients and turn them into value-added products for the agricultural sector. So, in a nutshell, what is water to return? It proposes an integrated solution for treating this wastewater from the slaughterhouse while recovering nutrients. This way, we can consider the wastewater treatment facilities inside these bigger industries maybe turned into biorefineries. It is an innovation action co-funded by the European Commission under Horizon 2020 program. It is built, as mentioned, on a bottom-up approach based on a current market demand. It started by July 2017. It will finalize by March 2022. And the Commission will cover practically 6 million euro from the 7 million euro budget, and it's coordinated by, as mentioned, by BioAzul company. So, what is the system itself? It's composed of 3 treatment lines plus an energy recovery module. Each of these treatment lines have produce a concrete secondary raw material that can be the basis for manufacturing agronomic products. So let's go line by line. The first one is called water line, and it's because it is the first one treating directly wastewater from the slaughterhouse. In this case, we treat the wastewater and obtain a nutrients concentrate, which will constitute secondary raw material number one, with which we will manufacture a biofertilizer. What happens in here? We have two big parts of this treatment line. On the one hand, an SBR, which is a wastewater treatment technology, plus a filtration unit. When treating the water in the SBR, we obtain two parts, let's say. One of them is the treated water that goes to the filtration unit, and from there we obtain the nutrients concentrate, and the other part is a sludge. The sludge will be feeding the following treatment line, which is called sludge line. In this case, we have a pre-treatment plus a fermenter, and what will happen here is that the sludge generated by the SBR from the water line will go through a fermentation process with bacillus. We will obtain, on the one hand, a solid fraction. It will be a secondary raw material to further manufacture a biostimulant, and the liquid fraction will feed the anaerobic digester that constitutes the energy recovery module, and we will generate energy as well. But within this anaerobic digestion process, there is CO2 which is released, and it's captured by the algae line. In this case, this microalgae included in the algae line will capture CO2 and get feed of it, and we will obtain a microalgae biomass, which is secondary raw material number 3, and it will be a biostimulant as well. So these agronomic products will be free of pathogens, heavy metals, and it should be ready for commercialization at European and international level. Key innovations, of course, the integrated treatment system with the 3 treatment lines, the 3 secondary raw materials, and the 3 agronomic products. These constitute a new business model based on a circular economy approach and on industrial symbiosis, because 2 sectors that in principle should not be really related among them, at the end, they can benefit each other from collaborating. So it provides business opportunities to wastewater treatment sector, energy engineering, consultancy companies, manufacturers of agronomic products, slaughterhouses, meat industry. Where are we working actually? We are working on a demonstrator, which is located in a real slaughterhouse, real working slaughterhouse called Matadero del Sur. It is located in Salteras, which is a municipality nearby Seville city in the south of Spain. It has a treatment capacity of 50 cubic meters per day out of the 150 of the total daily flow of the slaughterhouse. We are treating only 1/3 because this is an innovation action project, so we have demonstrators and not real scale applications. That is why we only treat 1/3. And this is the appearance, how it looks like at this point. So what we saw in the scheme is included in here, and I will show you picture by picture each of the systems. This is the complete water line with the SBR and the different tanks, and well, the filtration unit, you cannot see it there because it's on the other part. But this is the complete water line. This is the fermentation unit, the sludge line, followed by the energy recovery module with the anaerobic digester, and the big pond is the algae line. The 2 small ones are the inoculum ponds, and this is what we are working on at this point. Results up to now. The whole system is installed, as you have seen. Water line is properly running since the first half of 2020. We set an analytics protocol to check how the treatment was working, and it's constantly applied since September 2020. The sludge line is currently being started up, and the initial results will be available soon. And the anaerobic digestion tests on site, because there were several ones at lab level, are being started up at this moment. So what can we say about the available results up to now that comes from the water line? According to the regulation, we can we have to fulfill one out of two conditions. We have to fulfill the concentration of different parameters within the treated water or a percentage of reduction. These are the parameters that have to be checked: biological, biochemical oxygen demand, chemical oxygen demand, and total suspended solids. So when checking the effluent from September to May, we can see that all samples fulfill legislation either regarding the concentration or regarding the percentage of reduction. In most of the cases, the concentration of BOD is below the permitted levels, and in those cases in which it doesn't happen, they fulfill the percentage reduction. The same happens with the chemical oxygen demand, and the same happens with the total suspended solid. So the treatment, wastewater treatment is running properly, and we are currently setting up the fermenter to see how much we can produce, because this is the next step, to see how much we can produce and find out if we can take this to the marketable scale for the agricultural products manufacturer. So potential clients of the system, it's actually a very flexible system, because we can install the whole thing, but we can also think about each concrete situation and install part of the modules or the treatment lines. And it's highly replicable, because the kind of wastewater we can find in, for example, slaughterhouses or meat processing industry is very similar. So at the very beginning, at first stage, the early adopters, of course, would be other slaughterhouses, and in a second stage, meat processing industries, and of course, other beneficiaries would be agronomic products distributors, and obviously the farmers. This is the consortium we have. This is the geographical distribution, and that's all from my side, I think. So if you have questions, I'm here.
Thank you. Thank you very much. They're both very interesting projects, very highly innovative. So really, thank you for sharing the knowledge with us. So yeah, I've got a few questions, but before that, is there some curiosity that you would like to ask the other projects, or you're interested in?
Yeah, I thought it was a really interesting presentation. Like really innovative way of upcycling. So something that people are just trying to get rid of, I'd imagine. You mentioned that there was an element of kind of capturing CO2 as well. So I guess to me that's a really important topic as well, with not just kind of recycling, but also just with climate action, trying to capture some of the carbon that's in the atmosphere. So I guess have you? Is there a way to maybe perhaps have a mechanism like that more standalone, or to have kind of more CO2 capturing using that approach in other industries?
Well, in this case, it is designed in a way in which the CO2 capture goes directly to the algae pond. So we use it on, it's not a way of, the aim is not capturing the CO2 to not being released to the environment, which is like a secondary purpose, obviously, and it's good for the environment, but it's the idea is taking it to feed the algae directly, because if not, the algae treatment does not work properly. It's feeding the algae growing there. So obviously, as a secondary impact, obviously it's very important for the project, because we are again, talking about circular economy, and it's important to take it into account, but it's not the primary objective of this part.
Okay, it's really interesting to hear that. Thank you.
Thank you. Dr. Zapata, do you have some questions?
Well, it's actually quite impressive for me, because it's true when talking with the farmers and with the manufacturers and associations and so on. It's true that farming sector is including these technologies progressively, and I'm not sure if it's still very difficult to bring people on board to actually test this kind of technologies, or if you have still a barrier regarding traditional farming and so on, because I don't know if including technologies in this field is always easy, or if it is easy everywhere.
Yeah, no, there's definitely it's definitely much more difficult, because you're going up against an industry that's very traditional, like what we would find, particularly in Ireland, where we're looking at the dairy industry. You would have a cohort that are very ambitious with taking on technology, but the vast majority would be a bit more reluctant, a bit more hesitant. So what we find is delivering really convincing use cases, showing where they really see the value, and try to make it as easy as possible for them to adopt this technology. So the vast majority would have smartphones, for example. So can we integrate with the smartphone as much as possible?
Yeah.
And to make it very, very easy for them. Really, that's what our main objective is.
Sure.
Yeah, I personally think that both projects are based on a sort of data collection from stakeholders. So, of course, engaged in the agricultural sector. So I was also wondering, like, how do you engage, or did you engage with them to retrieve data, and how would you push them to adopt these technologies in both projects?
This is somehow complicated because in our case, we're talking about wastewater, and this word is like quite ugly for everyone. No, it's are you going to irrigate something? It's not the case in this project. But when you talk about treating wastewater and use reclaimed water for irrigation, which is another possibility, people get a little bit reluctant because you're talking about wastewater. And this is very difficult sometimes to overcome. And when approaching stakeholders, because obviously you have to explain, okay, we are going to use this wastewater, we are going to produce some agronomic products that you will be able to use in the on the field. It's complicated. So we are elaborating different kinds of stakeholders surveys divided by sectors. We have 5 different kinds of surveys. This is also very important for us for all the activities regarding market potential, business models, and so on, and social acceptance, because it will be the way of actually building our business model that will be divided into smaller ones. So we are trying to approach them, make this, we will have 2 kinds of training workshops and seminars for stakeholders to actually get also information from them, know what are their main concerns and so on, to actually build up this business model strategy.
Yeah, it's always very difficult because that's the idea in people's mind that need to be changed a little bit, of open to these new possibilities that are new to anyone. So of course, it's quite a challenging task. Dr. David, would you like to add something? Yes.
Yeah,
please.
Absolutely. I think, you mentioned that education is such an important aspect of this as well. And, educating the industry on the value of the data that they have, that even if they don't know they have this data, just, I guess, the first is just educating them on the value of the data and what could be achieved if they were willing to share this data. And then on the other hand, perhaps you have industries that they are collecting data, they're processing it themselves, but they're very reluctant to share it, because they would be saying, potentially that data is their value proposition, or it's their intellectual property, or it's their commercial head. So it's showing as well, if they can share to some degree, that they can benefit not just themselves but their whole sector. And I think that's definitely another important message to be able to communicate as well. If you can share your data, everyone can benefit.
Yeah.
I was wondering, in the case of the CYBELE project, because obviously the system is based on data collection, storage, transmission of data. So how do you deal with security and privacy threats?
Yeah, absolutely. One of the aspects of the project deals with security. And what we do is, let's say we have an organization that has data and they want to be able to share it on our platform. They can actually, firstly, it's maintaining a secure database. So we manage access to that database very, very securely. If they want to share data, we're actually using blockchain technology to allow them to, really securely grant someone, a short-term access to that data, or to grant certain permissions of access to that data. So, really central to the project is this idea of, if you're sharing data, you're sharing it on your own terms, and they can define who gets access to data and how they can access it. And this is, again, we're integrating blockchain technology into this as well.
Thank you very much. Thank you both. I have another question for the Water2Return. I was wondering, what role do the geographical differences play in this? Because I guess can it affect the treatment of the wastewater in terms of the availability of facilities or different water conditions and so on?
Well, the main differences between our demonstrator and other potential installations, the composition will be more or less the same. There will be no big differences, but the concentration will be different, of course, because it will depend not only on the amount of animals slaughtered, but also the kind of animals slaughtered. This can vary a little bit. So therefore, that is why this system is so tailor-made for every potential client, because we have to check a little bit what they have, and starting from that, we can design one kind of installation or another. But when talking about slaughterhouses, the difference should not be too big to actually replicate it.
Okay, perfect. Thank you. Now I've got a question for both of you. What kind of technical or non-technical challenges have you faced during the project, during the implementation of the project? Dr. Davy, you can start if you want.
Yeah, absolutely. I think right across Europe, a lot of research projects, particularly ones that involve demonstrators, were impacted by COVID. As well, we're all working from home, but the pilots where we had to go out and collect data or interact with farmers in the field, that was quite challenging. And in fact, we found that we had to kind of reorganize the project to be able to deal with that. So in areas where big organizations were coming out of lockdown, we were able to prioritize data collection in those areas. So that would be one, and I think that it shows a really strong consortium if you're able to deal with such a shock like that to the organization and still be able to progress and work on time. Another aspect I think was I guess being able to one of the use cases we had in mind, we had to actually change direction for the use case during the middle of the project, and just to make sure that that new use case aligned to the project's objectives and goals. And I guess it was a rigorous progress to go through. So that's kind of from the kind of the non-technical side. From the technical side, one of the main challenges we had is, again, what we're trying to do is build these abstractions over high-performance computing. But high-performance computing, different centers in Europe, they have very different ways to interact with them, very different ways to be able to use them. And that was quite a challenge as well, to be able to develop something that could abstract those quite drastic differences, so that from a customer's perspective, they were able to deploy some piece of software, and it didn't really matter which HPC they deployed onto. So that was an interesting challenge that we had to overcome as well.
Do you mean also for users to use these softwares and get used to how they work as well?
Yeah, exactly. Yeah. So, for example, one of our users would be a typical data scientist. They might have experience in using machine learning libraries or Python, which is a software development language. But to be able to run that, it's very different to run that on your own computer or on your own server than to on a HPC. So we wanted to try and make that very seamless. So what they did run on their server, they could run on a HPC. So taking that and transforming it into that mechanism so it could run on a large system as well. That's that was really core to the challenge that we were trying to solve.
Yeah, that's quite a big challenge. Thank you very much. Dr. Zapata, would you like to say something about it?
Well, in our case, regarding non-technical issues, obviously this year has been a challenge for everyone in every single aspect, trying to build up and run a demonstrator from home, it's not possible. So we have also extended the project a little bit and reorganized things because of this. But regarding non-technical issues, non-related with this special situation, again, we are talking about two sectors a little bit complicated regarding social acceptance and so on. One of them is wastewater, another one is slaughtering industry, which is not very popular as well for many people. So we have working not only on environmental assessment, of course, but not only life cycle assessment or life costing, cycle costing, but also social life cycle assessment, because it is a very, very important aspect in our case. Because if we want to actually have a market, we need people to understand how it is, why it works, and why it's beneficial. At the same time, we are talking about two industries. That is why we have the trainings I was mentioning before, in which, wastewater slaughtering industry, they have wastewater, they want to treat them. Whatever you do afterwards, it's okay, but they do not see the whole picture sometimes, because they focus on their concrete situation. And the same happens with farmers. We want a fertilizer or a biostimulant. It's not really up to me whenever it comes, and why it's important I use this one and not another one. So this, again, raising awareness is very important. And from the technical point of view, basically, when we wrote the proposal, and obviously we have to make assumptions about how much of every single nutrient or how the composition is going to be of the wastewater, how much we can obtain, how this can work, which is going to be the yield or the efficiency of the system. And then when you face reality, you realize that maybe some of these things are not the same as you were imagining before. So you have to readapt a little bit. But, well, it's something that happens in any kind of demonstration project. So
yeah,
nothing...
that's the struggle between theory and practice, I guess.
Yeah, obviously.
Thank you very much. We have a question from Anne de Moisy. I apologize for the pronunciation. she's asking, what do you consider as the main issues when using ML models for wet ear counting?
Oh, sorry, yeah.
I guess it's for
the wheat ear counting. So the organisation in that is the University of Strathclyde in Glasgow, or sorry, in Scotland. So they're using convolutional networks to be able to look at these, and they're what they're looking at is it's wheat ear counting. It's semantic segmentation is the technique that they're using. So you look at a picture and you try to label each pixel in the frame. Is it a wheat ear? Is it just part of the background, or is it part of the leaf or part of the stalk? And so that initially that's kind of what the algorithms they're using, and they're training this on drone imagery data, collecting images by hand, labeling the image by hand, and then getting their algorithms to be able to perform these kind of semantic segmentation masks. The difficulty in the project, as with many of them, is getting access to the data and labeling the data, and also making sure that their algorithm can be generalized to crop produced in other regions or in other areas. So it's taking account of daylight, potentially shadows on the fields. So there's some of the challenges that they're looking into.
Thank you, Dr. Davy. Thank you very much. Now I've got one last question, which moves a little bit away from the technicality of the projects themselves. What's the best part of working in a European project for you? Dr. Zapata, you can start if you want to.
Well, I think it has actually a lot of advantages. And I'm talking as a company, let's say, because when you come from an SME, it's complicated sometimes to test new things in different environments or geographical areas or different industries, because there is a lot of risk. Actually, you have to invest, and it's complicated if you are a small company. But when you build up a group in which you have the best researchers, the best end users, the best ideas all together, and you have the European Commission just up there trying to help you, financing you, is really, really useful, I think, for everyone. Obviously, you also enlarge your network of contacts. You get in touch with people with which maybe you would have never had the chance to connect, and you realize about the potentiality of your ideas, actually. And it's really from a personal point of view, really enriching, because you know a lot of realities that maybe you were not aware of. And I'm also talking about the work with the other countries outside Europe, with which we work a lot. We have this opportunity, and you realize how they face the technological and non-technological challenges in a very different way, and then it's very enriching, actually.
Yeah, it's great because it kind of makes you open your mind to loads of possibilities. Dr. David, would you like to add on that?
Yeah, absolutely. For me, I think it's that, and again, just to mirror Pilar's comments, it's that access to expertise. These are some of the best researchers in Europe that we're working with, and they're tackling these really, really difficult problems. And also, when you're working with end user businesses, you can see, firsthand the impact that these results of the projects are going to have. In some instances, it could be completely transformative to the businesses and make them a lot more cost effective, a lot more efficient. And to get that feedback during the project is amazing.
Yeah, absolutely. Thank you for your inputs. And okay, so I guess we got to the end of the episode. I really thank you both for accepting our invitation to the series. And thank you very much for your contribution. So I'll just wrap up, and I'll wait. Well, we'll see one another in the next episode next week. And thank you very much again, Dr. Davy and Dr. Zapata, for being here today.
Thank you very
Thanks
much.
a lot to you.
Have a nice day.
Same to you.
Bye-bye.
Bye.
Bye-bye.